So, welcome back, friends. Today I am back again with a geometry problem, more of a conic section problem, which includes some concepts of complex numbers. I would like to thank Martin for suggesting me this problem. In this way, we can look back on complex number and the geometry of conic sections too. So, I would like to request you people to give this problem a try and then come back to see the solution. So let's begin. In this problem we can see that we are given with three collinear points A, B and C whose coordinates are given by the complex numbers z1, z2 and z3. Let me write it like this. A, it's represented by z1 and z1 is simply ai. So 0 comma a, if we write it in coordinate form, and the point B, it is also represented by z2 and the coordinates of z2 is something like this. So like this, and the C, the point C is represented by z3, which is given by 1 plus ci. If we write it in coordinate form, it will like 1 comma c. So here obviously a, b and c are real numbers, there is no doubt in this case. These points, 3 points a, b and c are collinear points. So what is mean by the collinear points? The collinear points, it simply means that a, b and c, they always lies on a same line. They lies on a same line. That is what mean by collinear points. So I can say that they cannot form a triangle, right? Or if they form a triangle, the area of the triangle will be 0. So what will be the area of the triangle formula for three vertices? A is given by a1 x1 y1, b is given by x2 y2, and c is given by x3 y3. Then what will be the best formula to find the area of the triangle? The area will be simply given by this determinant, and something like this. If we could solve the determinant, then we will find the area. Now in our case, we can notice that A, B and C, they are collinear point. It means that they cannot form a triangle, or if they form a triangle, the area of the triangle will be 0. We will use this formula to find a relation between A, B and C. Let's apply the formula. So if we apply it, it will become something like, say, half. Our first point, A points 0 comma a, half comma b, and then it's 1 comma c. So first 0 comma a, and then it is half comma b, and then it is 1 comma c. And we know that this determinant is nothing but 0. So we have to expand this determinant and find the relation between this a, b and c. If we expand this determinant according to the first row, then we can observe that it will become something like So 1 1, something like this. If we calculate it, see, then it will become like this, and if we calculate this, then half minus 1 minus half plus, so it will become something like this. Let's see, it simply gives us that a minus 2b plus c equals to 0. If we can simplify it more, then it will become a plus c equals to 2b. It is given. Now comes to our original question or prop. It is given that the curve equation of the curve z is given by z equals to this relation z1 cos 40 to z2 cos square sin square t z3 sin square 40, and now we have to use this equation. Let me write it for you. It is given by this 2z2 I hope I write it perfect. Yeah, I write it perfect. So if we put the values of z1 z2 and z3, we found that z1 is given by ai, that is cos 40, z2 is given by 1 by 2 plus bi cos square t sin square t, and z3 is given by 1 plus ci sin 4t. Now what we can do, we can simply multiply these things and find the relation and expand it. So if we do so, the result will follows like this. See, 2.5, it will become 1. There is the cos square t sin square t part, and this becomes 2bi cos square t sin square t. This becomes a sin 4t ci sin power 4. I hope I make it correct. So now if we separate the real part and imaginary part, it will looks like something like this: cos square t sin square t plus sin 4t plus I into everything a cos 4t plus 2b cos square t sin square t, and it is yes. So this is our imaginary part and real part. Now we will use a simple relation what we have find before, and the relation is the relation number 1, that is this thing a plus c equals to 2b. If we use this relation, let me put it like the same r for it, and let me write it the same r. In the place of 2b we will put a plus c, and then it will become like this. So now if we expand this whole thing, it will be a great big thing like this. Cos 40, let me write common, take common a, then it will become cos square t sin square. And if we take c common, then it will become the same thing almost, something like this. Now what is our r? Our r is the real part. And what is our real part? Our real part is cos square t sin square t plus sin to the power 4. So we can take common sin square t. Now if we take sin square t as common, it will become cos square t plus sin square t in the real case. And in the imaginary case, if you look closely, then we can take common from here cos square t. So if we take common cos square t, it will again become cos square t plus sin square t. And from here we can take common sin square t. So if we take common sin square t, it will become something like cos square t plus sin square t. So if you simplify this whole thing, we are simply left with a very simple thing: sin square t as I a cos square t plus c sin square t. This is the z. Here we simply write z equals to x plus iy. So if we compare the real part and imaginary part from the left and right, then we can simply observe that then x equals to sin square t and y equals to a cos square t plus c sin square t. So we can write cos square t as sin square t, so we can write this as 1 minus x, right? Sin square t plus cos square t equals to 1, so you can write cos square t equals to 1 minus sin square t, right? So like this, and we can write this at cx. Obviously know what type of equation this thing represents, right? So it will become something like this, and yes, it is the equation of a straight line. It is the equation of a straight line, which in the question we have to know. So I hope you like the video. If you like the video and like our procedures, then please do support us and subscribe us. Thank you very much.